Well, good morning and thank you.
Всем доброе
Thank you for
дело.
the invitation.
Доброе утро. Большое спасибо за приглашение и за добрые
I'm not able
слова.
to understand a single word from what he said. I think he said something about me. So I'm not really fluent in Russian. Okay, so I can try to speak a kind of English or Portuguese. If you have any questions, please raise your hand and I will try to repeat again. Okay. It's okay if you don't understand me. You say that my wife does not understand me quite a lot, so it's okay. Today I have a challenge to try to talk about API test automation. So I was challenged to do a kind of a workshop. Okay. For me, in a workshop, it's for less than 16 persons. Okay. And today we have a little bit more than 16, so it's not possible to do it hands-on, but I will try to do it in two different phases. The first one, I will give you some concepts. I will talk about API test automation, and after a small break, we will talk about some tools. So I will show you 3 different tools. I will show you how to use these tools, but I will not tell you what tool you should choose. Okay? That's for you. You need to understand your context, and then you can choose the best tool for your needs. Okay? So first, starting about APIs. What is this? What is an API? So most of you know this API, application programming interface, right? That's what it means, these acronyms. And it's not something new. Actually, it started in the 60s, where these APIs were just libraries that allow us to connect, to interact with the operating system, with the hardware. So that was the beginning. It was a programming interface, right? Later on, in the 70s, with the distributed systems, we started to have the same concept, but for remote access. So it was possible not just to connect to the local hardware, to the local APIs, but also to the remote service in remote computers. And in the 90s, we start to have something different with the message-oriented middleware, service-oriented architectures, okay, the SOA. That was a big word on that time. Also with the SOAP, Simple Object Protocol. So basically, it was possible to call remote APIs, exchanging XML files from one side to the other. Okay, but most interesting is that in the 2000s, we start to talk about about REST. Okay. This representational state transfer. So it means that we are able to change objects from one side to the other, but without keeping the state. So it was a much more simpler and faster and lighter approach to SOAP. We could do basically the same, but in a simpler and faster way. And in the already in our time, we start to talk a lot about microservice. So we moved a lot in the API story from the initial times where we just used APIs in the same computer to APIs on remote computers, to services that were based on APIs, and now we are talking about APIs inside the solution. So we have a solution and we have communication through APIs inside our own solution. So this means that the number of APIs increased a lot during these last years. So when we are talking about APIs, we can see this as a clear defined method. So basically it's like a set of functions that we can call. Okay? It's public available, it's well defined, so we know what are the inputs, we know what are the expected outputs. So we can interact with the system using these APIs. And nowadays you can find private APIs, but also a lot of public APIs, right? Almost all the main service in the world today are available through APIs. You can do shopping, you can do maps, you can do lots of things, whether, finance, transactions. You can do a lot of that using public APIs, right? So you can connect all these different services, and you can add value just by connecting service, right? You don't need to implement everything from scratch. And when we are talking about API testing, basically it's to interact with this service instead of interacting with the user interface. So it's just a different type of interface. Okay. The challenge in our days is that these interfaces are not just for programmers, not just for developers. In the past, the first APIs were just for developers, right? So they can use unit testing to test the APIs. In our days, APIs, they are just another interface, like user interface, and sometimes the only interface available for the tests. Is anyone here doing API testing? Yeah. Oh, good, great. And manual or automated? Automated? Okay, a few, nice. Okay. So probably some of the things that I will say, they will not be new for you, but I think it matches against these numbers. So you have that reference. It was a recent study from SmartBear, and it says that the majority of testers in our days, they are already responsible for testing both user interface and also APIs. Okay. So it's around 60%. Okay. And for the rest of you guys that are not yet testing APIs, I think sooner you will do it, because the number of APIs will increase even more. Okay. So if you are not yet doing it already, I think you should get ready, because you will do it. So for tomorrow, what can we expect about API testing? Well, you know that in our days, at least in the context that I know, could be a different, and I don't know, to be honest, the context here. So if it's not applicable, please let me know. Teach me also something. But in the context that I know, you see a lot of these agility requests. It's trendy. Everyone wants to be fast, right? To be faster. So they need to release these faster deployments. They need to have faster versions. It's a crazy trend in our days. Everyone is trying to release faster, right? Instead of the quality, we start to measure the number of deploys that we are able to do by day or by hour. So in Portugal, we say that shit in, shit out, right? I don't know how that will be translated. But it's not just because you are releasing faster that you are releasing better, right? But most of the companies today, they are just focused on releasing faster. Okay? So they are trying to make it faster, and they use that like a measure of quality. Okay? In my opinion, quite badly. But it's our world, so we need also to cope with this. We need to release it faster, and that means that we need to embrace also this DevOps practice, but also continuous delivery and continuous deployment. So we moved from continuous integration. Anyone doing continuous integration? Okay, and the next stage, continuous delivery. Only 1, 2, continuous deployment. Okay. You know the difference between all of them, right? No? Let me explain. So continuous integration, basically it's to grab the code and to compile it, right? Using tools like Jenkins. And that's quite easy to do, quite easy to implement. When we move to continuous delivery, what they call the next stage, it's to grab this code, to run all the different set of tests, to move it from one stage to the other, from one environment to the other. But the last stage, to go or not into production, it's a manual decision. It's a business decision. It could be just a click in a button, but it will be always a business decision. Okay? And continuous deployment, it's the extreme. It's like the nirvana. It's when you do all of this, but automatically. So a developer is pushing the code, it goes through all the different tests, different stages. In the different stage, we will run different tests also, and then it goes into production without any manual decision in the middle. It was just automated process. Okay? That's continuous deployment. Of course, it also depends on the context. Today, in conference all over the world, I'm seeing talks about continuous deployment like it's the best thing in the world. Okay. Well, if you have a website for news or a social network, that could be acceptable, right? If you have like an airplane, a software for an airplane, you don't want that live, right? At least I don't. And believe me, I have already some strange stories about software inside airplanes, and that's not the best thing. So we don't want to have continuous deployment for that. If it's a satellite software, if it's critical software, of course we don't want deployment, continuous deployment. But in any way, unless you are in a specific market, sooner or later you will have someone asking you to do this, continuous delivery, continuous deployment. And then hopefully we will also have continuous automated testing. Okay? If not, it means that you will need to repeat all these tests over and over again. So it's impossible to talk about continuous deployment, continuous delivery without also talking about continuous automated testing. Okay? And let me give you a small hint about continuous automated testing. The challenge is not on the implementation itself. The challenge is to decide what amount of tests you need to do at each stage. Okay, that's the secret sauce. Okay, most of the teams that I'm working today, they started by trying to move all the set of tests through each stage. Okay, that's the first mistake. So you need to understand what needs to be executed at each stage in your pipeline. So the last one, it's about microservice architecture migration. As I said, today I see lots and lots of service or companies moving from traditional architectures to microservice. Even the ones that are more traditional, like for example banks. Okay. Today in Portugal, for example, we have banks that are moving from mainframe into Java. So they are moving from a monolithic architecture, big one, into microservice, where all these different components in the financial transactions are served as a service with an API, independent service. So this means that instead of just deploying one big thing, one big bank, we can deploy all these microservices independently. And for testers, you know what it means, right? lots and lots of regression testing. So if we are not prepared to do all of these tests, basically we will not do anything else for the rest of our lives, right? You know the term exhaustive testing, right? And everyone knows that it's impossible. But believe me, you can be exhausted running all these tests. And the last part, it's Internet of Things. Okay. Do you have any device that can be called an Internet of Things device? Like a smartwatch, like a smart home appliance? Do you have something like that? Yeah. Okay, a few. For most of these, you will have a dedicated interface. Okay, let me show. Okay, I will talk a little bit more about this later. But for most of these, you will have a dedicated interface. But for some, you also have servers that will provide these REST APIs. So you can see all the number of APIs that will increase exponentially over these years. Okay, and we can expect even more. The total amount of APIs that are available today and the ones that they expect to have in 1 year, in 3 years, in 10 years, it's crazy. So what are the main concerns when we are talking about API testing? So the first one is functionality. So if my API is returning the right results, right? So this is the basic activity for a tester, right? You need to provide some inputs and you need to validate your expected results. But in our days, it's also important to take care about the performance of these APIs. Why? Because you have lots of small requests. So you don't have one request just sent to the server. You have all this amount of device that will send small requests to your API. And if you don't take care of the performance, your service will not be available. And that's the last point. Okay. Security. Security, it's also quite important. Because in the past, for example, if we look to the energy area, energy sector, in the past, the only thing that you could find on the web about energy was like reports, how much it was produced, right? Nothing else, like annual report. And later on, you could connect to this interface to find out the energy that was being produced on real time. But today, we moved further on that process. So today, it's also possible not just to read that data, but also to interact with that data. Okay. Before coming to this conference, I saw in the news in UK, they said that some Russian hackers, they were playing around with some energy companies in UK. Okay, so if you can control the energy API, basically you can shut down the lights for an entire country. Right? So security is quite important. I know some countries where that will be okay to turn off them for some time, but that can be quite dangerous, as you can imagine. So, of course, the last one, it's availability, also quite important. The service needs to be always on, right? Today, with the mobile phones, you don't expect them to fail. You don't expect the service to be online just between 9 and 6, right? In the old days, it was like that. 9, 6, turn off the computer, right? Today it's not like that. It's 24/7, right? So the service always needs to be online and responding on time. So when we are talking about Restful Web Service, it's basically an application program interface, and this is quite simple because it uses something that we already know quite well, HTTP requests. Okay, and it can use post, get, put, and delete operations. It can use more, but it can use also these ones are the most used. Okay. And probably if you test web applications, you already tested the post and the get. That the order there, it's important because you know CRUD, create, retrieve, update, and delete. That's basically the same for HTTP requests when we are talking about REST API. So post, it's create, get is retrieve, put is the update, and delete, it's the delete. So as I said before, there is no state between calls, and it's a lighter approach when compared with SOAP, especially because we are talking about JSON instead of XML. So the amount of the data and the processing of that data, it's much simpler. So it takes less time to process, less processor time, less memory, but it's also more efficient when we are talking about networking. So the amount of data, it's much smaller. If you look to a text file, and if you try to store it as an XML file with some schema on it, you will see that the size of the file can increase a lot. If you try to keep the same file in a JSON format, it's much more simpler. So some constraints. This decouples the consumers from the producers because we are splitting the service, who is producing the service, who is calling it, stateless existence, and this is quite important because also enables us to use cache. There is no state, so we can cache the response. And also the layer system. How? Providing the interface. We don't care about what is happening in the different layers. We just have this API. In the design patterns, this is called a facade. Basically, it abstracts all the business logic behind and providing the same interface. So this a uniform interface. For IoT, and just have 2 slides. Of course, JSON is quite good for this because it's schemaless, so we don't have the same challenge as the XML. We have a minimal set of the data types from JavaScript itself, and it's human readable and easily parsable. So that's quite important. We can read the data. We don't need a specific tool for that. But it's also easy to transform that data into something that can be used later on in our APIs. Because the parsers, you have parsers almost in any language because it's so simple to parse. So for the IoT device, typically they need network traffic optimizations. They need to be small. We are talking about devices that could be the case that they are not always on. And when they connect, they need to have an optimized connectivity. And also the amount of computation, because we are talking about device that could be limited, not just on the amount of computation, but also memory, storage, and especially power consumption. So all of these needs to be quite optimized. So, of course, REST is not optimized for this. You have specific protocols that are optimized, but the disadvantage is that you need to learn a new protocol. You need to have tools to interact with these protocols. So what you see in our days, it's IoT hubs. So you have IoT hubs. It could be a physical device. It could be just a service in the web that will allow you to interact with these hubs, with this IoT device acting as man in the middle. So basically it provides a web interface, and then it connects to all the IoT device using dedicated and optimized protocols. Okay, optimized protocols to interact with these tools. One example, it's the smart lights, where you have, for example, I know one model from Philips, where you have this web interface, and this app will interact with the lights using Zigbee. That is one protocol for IoT. But the app itself just provides a simple REST API. So if you already know how to test REST, you can move also to the IoT world. Okay, and that will happen. That will increase much more in the next years. Okay, so I think we are good to do a break now. If you have any questions, because next one I will start to talk and show 3 different tools. Okay, I will try to demonstrate. I don't know how it will work, so it will be a challenge also to me. But if you have questions, I think we have like 10 minutes.
Да, у нас даже немного побольше времени, так что не стесняйтесь. Если стесняетесь, то переставайте и задавайте вопросики. Кто-нибудь, поднимайте ручки, давайте. Неужели все понятно? Не может такого быть, чтобы на 100%.
Yeah.
О, yes, we have a question.
Hello. Did you work with Internet of Things testing? Did you do the actual testing of devices?
Yeah, I already started to work on the IoT for smart meters.
Sorry?
Smart meters, do you know that? So, for example, the UK, it's a huge market for smart meters. What is a smart meter? So you have in your home, you have gas, you have water, you have electricity, right? And how do you know how much you spend and how you know how much you need to pay? So in Portugal, someone goes to your home, or, you know, and they do that not every month. So it's like every 3 months. And every month you pay, and then every 3 months you get a surprise. It could be less, it could be more. So it could be a lot more, and you need to pay the remaining. Or every month you can call them saying, okay, this month I spent this amount of energy, so please send me the updated bill. Okay, but that's not efficient, right? That's not our days. So when we are talking about smart meters, basically it's this IoT device that is measuring what you are spending, and it's sending in real time, or in the end of the day, depends on the smart meters, to the central service. So they always know how much you are spending, and you don't need to tell them. And it's also easier for them to control fraud. Okay. So we are doing this test.
Okay. Was it challenging to test the device for security? Because, you know, it talks about how the IoT is very susceptible to attacks.
Yeah, it's true. And the problem with IoT is that it started quite, let's say, in a naive way. For example, today, if you buy a BMW car, most probably you will have a GPS SIM card, GSM SIM card. So when that started, no one cared about security. It was nice to have that, right? The guys from the mechanics said to change the oil from the brakes, and said, no, I don't. I said, yes, you have. Then I will check, and it was there. So the warning was there, and that's scary, right? Because they know more about your car than I myself that I'm driving every day, and all this communication was not secure because no one was caring about that. So security testing, it's a huge trend in our days. So they are moving all these protocols into a more secure layer. It could be secure communication, it could be authentication on the communications itself. So all these different layers. So is it secure already? No, it's not. Okay. it's a huge marketplace, and that's why we have security problems all over the world. Automotive, it's a good example. So if you are interested in security, I will say that you also have a good business opportunity there, because you will need that resources a lot. Okay. Yeah.
Отлично. Может быть, кто-нибудь еще надумал? Кто-нибудь? Нет? О, да.
Hi. So you told about advantages of REST API, and could you tell me, is there existed cases when SOAP API is better to use for architecture than REST API?
Yes. So first of all, when you need to keep transactions, you need to use SOAP API. So when you need to keep state between calls, okay, that's, I will say, in a simple way, that will be the main difference. If you need to keep the state between your calls, then you will need to use SOAP. Okay? And the good thing with SOAP is that we are used to have SOAP using HTTP, but you can use SOAP using different transfer protocols. So you can use SOAP using mail. For example, you can send an email with a SOAP envelope, and you can manage that transaction via email. But you can also connect different protocols. You can use service message bus, email, HTTP all together using SOAP. So it abstracts the transport layer. With REST, you have this HTTP layer. So if you are not talking about HTTP, then probably REST will not be the right solution. And again, if you need to keep state, you should also choose this REST state in your calls. Of course, the state, if you are talking with a smart light, that light will have the state, but not in your calls. Right? You tell the light, turn it on, and the state will be on. But your call will not have that information. If you need to find out the state, you need to send a request saying, give me your state. Okay? So it's much simpler. That's the advantage and also disadvantage. If you need more complex transactions, then with authentication, with different features, then probably you need to go back to SOAP.
Thank you.
Может быть, кто-нибудь еще? Желаете пообщаться с гостем? Нет? Но у нас еще будет куча времени.
Yeah.
О, бегу.
Hello, Joe. My name is Dennis, and I have a question. Why you divide functionality testing and security testing into two different points? Because as I understand, security testing, it is, for example, login testing, authorization test, and security transactions. It's logic, but you divide into 2 points. Why?
So the security and
Functionality.
security and functionality. Okay. Well, because they are two different things, in my opinion.
Would you provide real examples of security testing?
Yeah. So, for example,
different?
login. Even for login, and login, it's a security functionality, right? It's a security feature. So if you are able or not to log in, that's a feature. That's functional. But if you are able to overcome this security feature and to get into the system without valid credentials, that's security testing. Okay? So if I'm using the login form providing credentials, I'm testing the security feature of my app. And that's functional. It's a functional that I implemented. Okay? If I can access to data that I shouldn't be allowed to, if I can bypass this security, if I can use the login feature for something that it was not designed for, okay, that's security testing. Security testing, it's to penetrate into the system. It's to do, from the security point of view, things that I shouldn't be allowed to. Okay? So we shouldn't mix security as a feature of our app that should be tested from the functional point of view, from the security tests. The most known one is the SQL injection, right? So if you have something to search the database, that's functional. But if you try to inject SQL on that field and try to access the data, that's security. You can do both of them together. Usually they require different set of tools, different set of skills, but at least for the basic security tests, you can do that. It's the same for API. Okay, for API testing, we'll not talk about security today, but one of the tools is able also to do that, to grab the functional tests or what the tool knows from the API, from the functional point of view, and try to do some security tests. Okay, is it clear?